Let's continue to practice polynomial division. We'll divide x cubed minus 126 by x minus 5, and then afterwards we'll identify the quotient and remainder if they exist. First, we'll set up our symbols. We have our x minus 5 is going to be divided into our x cubed minus 126. We want to get rid of our x cubed, so we want to multiply the term x minus 5 by an x squared. This gives us x cubed minus 5x squared. Multiply this by -1 and then add it to the term above. Our x cubes cancel out and we're left with a 5x squared. Now pulling down the 126, this becomes a -126. We want to get rid of our 5x squared, which means we want to multiply our x minus 5 by just a 5x. We'll get a 5x squared minus 25x. Multiply this by a -1 and then add it to the term above. Our 5x squareds cancel out and we're left with a 25x. Again, pull the 126 down. And now we want to get rid of our 25x, so multiply x minus 5 by 25. We'll get a 25x minus 125. Multiply that by a -1 and then add it, and we're left with the number 1. So what this tells us is that our polynomial x cubed minus 126 can be rewritten as x minus 5 times x squared plus 5x plus 25 plus 1, where we have, this is our quotient, the number 1 is the remainder, and x minus 5 is the divisor. Let's look at another example. Now we'll find the quotient and remainder of x to the fourth minus 3x squared plus 1 divided by x minus 1. Setting up our problem, we're going to have x minus 1 dividing into our x to the fourth minus 3x squared plus 1. We want to get rid of our x to the fourth, so we're going to multiply x cubed by our x minus 1. This gives us an x to the fourth minus x squared, minus an x cubed. Multiply this by -1 and then add it to the term above, and we're left with a x cubed. And we're going to go ahead and bring down our -2x squared. Now we want to get rid of our x cubed, so we're going to multiply x minus 1 by an x squared. This becomes an x cubed minus x squared. Multiply this by a -1 and add it to the term above. Our x cubes cancel out and we get a -2x squared plus x squared. This is actually a 3 here. And the result that we'll get is a -2x raised to the second. We'll pull down our 1 and we're left with the following. So we want to get rid of our -2x squared. So multiply our x minus 1 by a -2x. And the result, we'll get a -2x squared plus 2x. Again, multiplying this by -1 and adding it to the term above, our -2x squareds disappear, and we're left with a -2x plus 1. We want to get rid of this -2x now, so multiply our x minus 1 by -2. We'll get a -2x plus 2. Multiplying by -1 and adding it to the term, our -2x cancels out, and we're left with just a -1. The quotient then is given by x cubed plus x squared minus 2x minus 2. And the remainder is given by a -1, because we cannot divide x minus 1 any further into our -1, since -1 has a smaller degree than x minus 1. In the final problem of this section, we want to determine if x minus 2 is a factor of 4x to the fourth minus 15x minus 4. We can use polynomial division to check if this is true. In the book, it recommends using synthetic division, but we're going to not use synthetic division since this is a rehash of polynomial division. And instead, we're going to look at the following fact. And the fact states that x minus c is a factor of a polynomial if and only if we evaluate our polynomial at c, we get that it's equal to 0. Another way of saying this fact is that x minus c is a factor of our polynomial if and only if c is a 0 of the polynomial. Here, set f of x equal to our 4x to the fourth minus 15x minus 4. And to check if x minus 2 is a factor of our f of x, we need to evaluate f at 2. Since x minus 2 is a factor of f of x if and only if f evaluated at 2 is equal to 0. So to check this condition, let's go ahead and just evaluate it. F evaluated at 2 is going to be equal to 4 times 2 raised to the fourth minus 15 times 2 minus 4. This is equal to 4 times 16 minus 30 minus 4, which is equal to 64 minus 34. Simplifying this is equal to 30. So what this tells us is that x minus 2 is not a factor. Specifically because f of 2 is non-zero.